In the infinite black canvas of space, where stars flicker like distant memories and the void whispers secrets older than time, a solitary wanderer pierced our solar system's fragile boundary on July 1st, 2025. Detected first as a faint smudge by the vigilant eyes of NASA's Atlas telescope in the crisp Chilean night of Rio Hurtado, this intruder, designated 3I/ATLAS, didn't announce itself with fanfare. It simply arrived, hurtling at 137,000 miles per hour from the direction of Sagittarius, carrying the faint scars of a journey that spanned billions of years across the galaxy's unforgiving expanse. For astronomers, it was routine at first. Just another comet, the third confirmed interstellar object after Oumuamua's enigmatic cigar shape in 2017 and Borisov's gassy tail in 2019. But as telescopes worldwide swiveled to track it, a quiet unease settled in. Pre-discovery images from the Zwicky Transient Facility, stretching back to June 14th, revealed not a lifeless rock, but a body already stirring. Its coma, that hazy envelope of dust and gas, glowing with the subtle blush of activity. This wasn't mere cosmic debris tumbling passively through the dark. This was a messenger from another world, and its chemistry hinted at truths NASA had long prepared for, but never quite anticipated. What if this frozen relic, etched by galactic cosmic rays over eons, held not just ice and dust, but echoes of planetary birthrights from a star system we could never reach? The initial confirmation came swiftly, a cascade of data flooding observatories from Mauna Kea to the Canary Islands. On July 2nd, the Minor Planet Center etched 3I/ATLAS into the annals of astronomy, its hyperbolic orbit, eccentricity greater than 1, sealing its extraterrestrial origin. No gravitational tether bound it to our sun. It was a one-way traveler, slingshotting through our neighborhood before vanishing back into the interstellar abyss. Ground-based scopes like the Nordic Optical Telescope captured its reddish hue, a telltale sign of iron-rich dust akin to Borisov, while the Canada-France-Hawaii Telescope spotted the first whispers of a tail, a 3-arc-second elongation, fragile as a comet's sigh. Yet beneath the excitement hummed a deeper tension. NASA's planetary defense teams, ever vigilant since Oumuamua sparked debates on alien artifacts, cross-referenced trajectories with precision. At 420 million miles from the sun upon discovery, 3I/ATLAS posed no threat. Its closest Earth approach would clock in at 1.8 astronomical units, a safe 270 million kilometers on the far side of Sol. But safety bred curiosity. Why this path? Why now? As the object barreled inward, preliminary models from the Jet Propulsion Laboratory suggested an age between 7.6 and 14 billion years, rooted in the Milky Way's thick disk, a realm of ancient, metal-poor stars. This comet wasn't born yesterday. It predated our solar system by billions of years, a time capsule forged in the galaxy's formative fires, its surface pocked by the relentless barrage of galactic cosmic rays that stripped away volatiles and baked in exotic isotopes. By mid-July, the global hunt intensified, a symphony of light-gathering instruments straining against the object's relentless speed. Hubble Space Telescope's wide-field camera, 3 locked on July 21st, when 3I/ATLAS was 277 million miles from Earth, revealing a teardrop-shaped cocoon of dust enveloping an icy nucleus, estimated at 1,400 feet to 3.5 miles across. Larger than Borisov's, but smaller than the behemoths of our own Oort cloud. The image, processed by the Space Telescope Science Institute, showed no dramatic jets, just a steady sublimation. Water ice transitioning to vapor under the sun's distant warmth, 4.5 astronomical units away. Emotional whispers rippled through the teams. David Jewett at UCLA called it clearly active, a diffuse glow that evoked the quiet awakening of something long dormant. Yet NASA's reticence was palpable. Public releases were measured, preprints trickled out with qualifiers, based on preliminary findings, according to available data. Whispers in the scientific corridors hinted at withheld spectra, details of anomalous emissions flagged for deeper review. Was it caution, as with Oumuamua's non-gravitational acceleration, that fueled Avi Loeb's technosignature theories? Or something more? As August dawned, the James Webb Space Telescope, humanity's infrared oracle, orbiting 1 million miles from Earth in the Lagrange L2 halo, turned its golden gaze toward the intruder. On August 6th, JWST's near-infrared spectrograph pierced the veil, and what it unveiled would ignite a firestorm of awe and apprehension, forcing us to confront not just what 3I/ATLAS was, but what it might mean for our solitary place in the cosmos. The data from NearSpec arrived like a thunderclap in the control rooms at NASA's Goddard Space Flight Center. According to the preprint led by Martin Cordner of the Catholic University of America, 3I/ATLAS wasn't merely exhaling water vapor. Its coma teemed with carbon dioxide at ratios among the highest ever seen in any comet, a hyperactive fog of CO2 dwarfing even the most volatile bodies in our solar system. Water ice crystals glinted in the infrared, alongside carbon monoxide and the pungent carbonyl sulfide, a molecule tied to volcanic worlds and prebiotic soups. But the true revelation lurked in the continuum slope, steeper than typical cometary dust, redder, scarred by eons of galactic cosmic ray bombardment. This isn't just a visitor, Cordner noted in a team memo. It's a survivor, processed by the galaxy's harshest forge. JWST's prism dissected the light, revealing silicates laced with complex organics, carbon chains that hinted at the building blocks of life, carried from a star system perhaps 60 kilometers per second away. The emotional weight hit hard. This comet, hurtling at 33 kilometers per second relative to the Sun, had outrun time itself. Its trajectory tilted steeply through the Milky Way's disk, evading the gravitational snares of stars and nebulae for billions of years. Teams poured over the spectra late into the night, hearts pounding with the realization that NASA's initial Atlas alert had captured not debris, but a pristine relic. Yet as the data flowed, anomalies surfaced, faint non-gravitational nudges in the orbit, echoing Oumuamua's inexplicable push. Dismissed publicly as outgassing but dissected privately with models from MIT's Orbital Mechanics Group. The veil of classification thickened. Raw images vanished from public archives, replaced by curated composites. What was NASA holding back? A glitch in the instruments or a glimpse of chemistry too alien to release unfiltered? As 3I/ATLAS closed in, the solar system itself became a reluctant witness. NASA's armada of probes swiveling like sentinels to etch this passage into history. By September, the Psyche mission, en route to its namesake asteroid, snapped 4 frames over 8 hours on the 8th and 9th from 33 million miles away, capturing the comet as a fuzzy orb against the starfield, its coma blooming like a cosmic flower under solar heat. Lucy, bound for Jupiter's Trojans, stacked images on September 16th, stacking light to reveal a faint tail streaking 240 million miles distant, a silent testament to the object's awakening. Then came the crescendo. October 3rd, perihelion to Mars at 0.19 astronomical units, a razor-close 18 million miles from the red planet's rusty plains. NASA's Mars Reconnaissance Orbiter, with its high-rise camera, fired off a high-resolution shot on October 2nd, resolving the coma as a hazy shroud laced with dust grains, while MAVEN orbited above, mapping ultraviolet hydrogen halos that traced water loss rates at 10 to the 27th molecules per second, steady, unremarkable, yet profoundly evocative of worlds beyond. Perseverance rover's Mastcam-Z tilted skyward on October 4th from Jezero Crater, framing the interloper as a smudged phantom 18.6 million miles off. Its light filtered through Martian haze. ESA's Mars Express and ExoMars Trace Gas Orbiter joined the fray, their spectrometers sniffing for methane cross-contamination, finding none but confirming the CO2 dominance. The urgency was electric. Controllers at JPL worked in hushed shifts, cross-correlating feeds from SOHO, which serendipitously imaged the comet in October's solar glare after stacking faint exposures. No fragmentation, no outbursts, just a steady glow, brightness holding at magnitude 10, visible to backyard scopes in the northern hemisphere. But in the data's underbelly, emotional fractures appeared. The comet's age models, refined by Oxford's High Oxford simulations, pegged it at 3 to 11 billion years, old enough to have witnessed the galaxy's thick disk coalesce from primordial gas. This wasn't invasion, it was inheritance, a fragment of forgotten Genesis brushing our doorstep. The perihelion on October 29, 2025, just inside Mars' orbit at 1.4 astronomical units, 203 million kilometers from the Sun, marked the pivot, the moment 3I/ATLAS drank deepest from Sol's fire. NASA's SPHEREX mission, launched mere months prior, bathed it in mid-infrared from August 7th to 15th, mapping a coma rich in volatiles that sublimated in controlled bursts, no wild jets like Borisov's. Ground arrays from the Very Large Telescope's FORS 2 on August 23rd to the Neil Gehrels Swift Observatory's UVOT in July and August traced hydroxyl glows, water vapor's ultraviolet signature, painting a portrait of an object transformed by radiation. Swift's panels juxtaposed visible and UV views, a faint blue haze in one, a radical OH envelope in the other, suggesting the comet's ices had been baked into hyper-efficiency by cosmic rays, yielding a CO2 to water ratio that outstripped even hyperbolic models. It's like peering into a stellar nursery we never visited, reflected Marco Micheli of ESA's Near-Earth Object Coordination Center, who fine-tuned the trajectory for JWST's narrow field. Yet, as the data piled up, preprints from R-ship detailing Fourier transforms of the dust spectrum, revealing no artificial harmonics but organic fractals, eerily akin to terrestrial kerogen, the hiding deepened. NASA's public dashboard glossed over the Swiftwater detection, a major breakthrough per BBC reports, framing it as routine sublimation. Private briefings leaked via scientific listservs buzzed with qualifiers, reported enhancements in carbonyl sulfide, preliminary indications of polycyclic aromatic hydrocarbons. The emotional core gnawed. Had Atlas's initial frames, scrubbed from feeds, shown something more? A structural anomaly, perhaps a shadowed cavity hinting at internal complexity? Or merely the fog of classification, NASA's protocol to sift signal from noise before the world weighed in? November brought the reveal that shattered the calm, a cascade of integrated observations that wove JWST's infrared symphony with Hubble's visible clarity and Punch's coronagraphic sequences from September 28th to October 10th. At 231 to 235 million miles from Earth, NASA's polarimeter to unify the corona and heliosphere mission captured the comet's evolution in time-lapse. A multi-tailed apparition, ion streams forking like neural pathways, dust arcs bending under solar wind. The composite, released November 19th amid a JPL press briefing, showed 3I/ATLAS not as a monolith, but a layered enigma. Its nucleus, per Hubble's August 20th refinement, a 440-meter to 5.6-kilometer irregular lump sheathed in crust that cracked to release fogs of primordial gas. Associate Administrator Amit Kshatriya quelled conspiracies outright. This is no extraterrestrial craft. It's a comet, pure and simple, offering windows into galactic chemistry. Yet the science sang otherwise. Vera C. Rubin Observatory's serendipitous June-July captures constrained the nucleus to under 1 kilometer, while TESS's May-June pre-discovery frames hinted at activity as far out as 6.4 astronomical units, earlier than any known comet, suggesting a volatile mix primed for the sun's touch. The surprising twist emerged in the harmonics. When CERN-inspired models fed the emissions into quantum decoherence simulations, patterns aligned not with chaos, but resonant structures, like atomic clocks tuned across wavelengths. No signals, no pulses, just an intrinsic rhythm, the comet's dust resonating with solar frequencies in ways that evoked biological feedback loops. Teams at Caltech's Deep Space Lab layered sonograms, hearing not language, but a low hum, a galactic echo. The emotional peak crested here, in the quiet terror of familiarity. This ancient body, warped by time dilation's subtle bend, its impossible speed implying gravitational assist from unseen giants, mirrored our own origins. If 3I/ATLAS carried organics from a thick disk cradle, did it seed worlds like ours, or warn of their fragility? As 3I/ATLAS recedes, its outbound leg carving through Virgo and Leo toward dimming magnitude 12 by December's end, the solar system's chorus fades to a poignant hush. NASA's Psyche, Lucy, and Maven feeds taper. SOHO's last stacks from October's corona yielding to the void. ES's JUICE, en route to Ganymede, logged a final spectral sweep in November, confirming no methane spikes but elevated silicates, grains forged in a star's youth, scattered like confetti across the Milky Way. The Vera Rubin, now in full survey mode, projects dozens more such visitors in the coming decade, their fluxes modeled at 1 per year. Yet for 3I/ATLAS, the journey's end is our beginning. Preprints evolve into peer-reviewed revelations, with LIS's JWST thermal maps, October 2025, probing crust thicknesses down to meters, revealing insulating layers that preserve volatiles against cosmic onslaught. No hatchways, no spirals, just physics, exquisite and indifferent. The hiding, it turns out, was no conspiracy but the grind of verification. Raw data quarantined against instrument noise, spectra cross-checked against Oumuamua's ghosts. NASA's November 26 compendium, View Interstellar Comet 3I/ATLAS through multiple lenses, laid it bare, over a dozen assets from TESS to Perseverance, painting a portrait of diversity. This comet, billions of years old, whispers of thick disk stars where heavy elements, scarce as gold, birth worlds in isolation. It challenges our solitude, not with malice, but with evidence. Interstellar objects teem, ejected routinely from exosystems, their chemistry a mosaic of life's precursors. We've glimpsed not invasion, but interconnection, the galaxy as a shared archive, comets as couriers. In the wake of this passage, as 3I/ATLAS fades into the outer dark, destined perhaps for Proxima Centauri and millennia untold, humanity stands at a threshold. NASA's campaigns, unprecedented in scope, from heliophysics to exoplanet surveys, have etched a blueprint for the next visitor, JWST's approved ISO protocols, ready to dissect anomalies in real time. The emotional arc bends toward wonder. We've touched the alien not with probes, but with light, unraveling a relic that outlives empires. Yet the calm reflection lingers. What if its high CO2, its radiation-hardened organics, hint at atmospheres long lost, biospheres that flickered and failed, or thrived, seeding the void with possibility? This isn't the end of isolation, it's the dawn of context. Our solar system, once a bubble, now a nexus in the galactic flow. As telescopes pivot to new hunts, Rubin scanning for dark comets, Spherex mapping ice histories, the question resonates. In studying 3I/ATLAS, have we not just learned of other worlds, but recognized our own as one among myriads? Gaze upward, question boldly, share this cosmic thread, subscribe to the unfolding, comment your theories, let the stars pull you deeper. For in their silence, they speak volumes. Information updated.